Exponents are when we make simpler a number multiplication of a number by itself. An exponent says how many times a number should be multiplied by itself to give us the result. Exponents are called powers. Here we have x to the power of 4. The 4 is what we call the power. X to the power of 4 it's the same as saying x times x times x times x. We have been learning the rules we need when using exponents. These rules are: rule number 1. When you have a base to the power of something times the same base to a different powers, give us the same base to the power of the first exponent plus the second one. Example: 2 to the power of 4 times 2 to the power of 3 give us 2 to the power of 7. Rule number 2. A base to the power of something all to the power of another exponent equals the same base to the power of the first exponent times the other. So it's like a to the power of x all to the power of y. It's the same as a to the power of x times y. Example: 6 to the power of 2 all to the power of 4. Rule number 4. Everything to the power of 0 always gives 1. Rule number 5. A base to the power of minus 1 gives 1 over the base. And a base minus an exponent different of 1 equals 1 over the base with the positive exponent. Rule number 6. A base to the power of 1/2 equals the square root of the base, and a base to the power of 1 over a different denominator equals the root of the denominator of the base. A base to the power of a fraction equals the base to the power of 1 over the denominator all to the power of the denominator, which gives the root of the denominator with the base all to the power of the denominator. Logs are the opposite operation of exponential. This means that the log of a number is the exponent to which another fixed value, the base, must be raised to produce that number. There are important rules to apply when using logs. These rules are: first rule, log A plus log B, it's the same as log AB. An example proved: it's log 8 plus log 4 has the same answer that log 32. Log A minus log B, it's the same as log A divided B. We consider log 20 minus log 4 give us the same answer as log 5. A to the power of B equals the same as B times log A. We consider it with example: log 5 to the power of 3 give us the same answer as 3 log 5. Log with base A, argument B, give us C. And for getting B, we could have A to the power of C. As example, we have log base 2, argument 4 equals 2, and 2 to the power of 2 equals 4. Log with base A, argument M, plus log base A, argument N, give us the same answer as log base A, M times N. As example, we have log base 5 argument 4 plus log 5 argument 6, which give us the same answer as log base 5 24 as argument. Log with base A argument M minus log with base a argument n give us the same as log base a argument m divided n. As example, we have log base 3 argument 8 minus log base 3 argument 4 gave us the same answer as log base 3 argument 2. With any base, argument 1 always gives 0. Generally are used to make things simple, as with this we can express big or small quantities. For example, in physics, the distance between the Earth and the Sun is 149,600 million kilometers, which in exponents can be expressed as 1.465 times 10 to the power of 8. Logarithms also help us to express really big or small quantities. In science, they are very used to know the magnitude of an earthquake, to describe noises, and calculate pH.